you want to develop a machine learning algorithm that can detect whether or not a community like a village or town in India has access to electricity based on its satellite image.
We're trying to put the algorithm and look at any random picture and say, okay, this place has electricity because it has so-and-so objects in the picture.
The problem is that we don't get that much high-resolution resource for that country, so we need to figure out how to improve the image quality and get more resources.
So one of the things we're really happy about this year is that among our 25 projects, I would say 4 or 5 are sort of part 2 or part 3. We like the idea that if people like something, then they want more. It's also the fact that no project worth its salt is completed in 10 weeks.
It really has been an evolution of one central idea, which has been, can we learn more about our world, about our society, from remote sensing data, from satellite imagery, something that's becoming more and more available and cheaper.
It's a very exciting subset of computer science, which is machine learning, where you're looking at how do you tell a computer to recognize patterns? How do you make it learn?
2 years ago, the team was looking at the question of how can we better understand our installed solar photovoltaic capacity in the US at a neighborhood level. This is something that wasn't generally available in an aggregate form. So what we wanted to do was automate that process. Over the course of those 2 years, the students were able to create algorithms that were able to estimate the net energy consumption of any neighborhood using satellite imagery data. Taking that to the next step, now that we're able to get insights about different communities and their energy consumption patterns, this has opened the door to looking more globally.
I worked on this project last year, so I have that experience from that has helped a lot, I think, this year. Last year we made another data set for building sizes and locations.
So another way our project differs from last year's is that last year they had 2 interns essentially go and draw squares around each of the solar panels that they saw in the city. That method works, and it's probably going to be kind of efficient because they have that expertise of drawing them, but it can also be very, very time inefficient. Most of the first part of the summer that we've done so far is developing this tool on Amazon Mechanical Turk, where we can post a satellite image that we've bought from Digital Globe or another source, and we would ask random users on Amazon Turk to essentially annotate like farms or buildings or objects that would indicate access to electricity in the area. My parents grew up in villages in India where they still don't really have very reliable access to electricity, so this project was kind of close to home, so which is why I chose to work on it, and it's been a really interesting experience working with it.
It's so easy to get lost in the weeds and the really interesting weeds of data analysis and visualization, but then having to take a moment, go up 10,000 feet, and really present it in a way that makes a difference. That's really the reason that we're doing all of this. Not just to have interesting problems, but to make a significant impact.